So another thing I am going to do is that I am going to stream this live so that if it happens that we are more than 300, then others can join us on YouTube. So I'm going to share the YouTube link for anyone who wants to join on YouTube. Good afternoon, everyone. I am having a little challenge. My internet connection is fluctuating and I'm getting locked up. I'm getting thrown out of the meeting. the implication is that midway into our class, it's possible that I drop off. If I drop off, the class can't continue. So I'll expect, and I sense that we will soon reach the limit of this meeting, which is 300. If that happens and I drop off, if we get to 300, I won't be able to log in again. So what I think we should do is one of the co-hosts should be able to let me in back if that happens. And sometimes it will mean that that person will need, if you're up to 300, that one person may have to drop off for me to come in. So I know this can be a little challenging, but I'm just explaining it so that we don't find ourselves in a situation where we're stuck because nobody wants to leave, nobody wants to step out. Okay, it's almost 3:30, and I think we should start now. So, co-hosts, you have the power to admit latecomers so that I can focus on what we're doing. So to help my internet connection, I am going to turn off my video. Good afternoon, everybody. My name is Michael Kunoji.
Good afternoon, sir.
Good afternoon, and together we will exchange ideas on descriptive statistics in the next 1 hour, at most 2 hours. So, like I said, I am going to turn off my video. Hopefully that can help my connection. Okay, so we will be talking about descriptive statistics in this course. And earlier I shared videos and I assume that we have all studied those videos. The time we have is not sufficient to learn how to calculate these statistics. And that's why we shared the videos. And if you have watched those videos, the things we'll be talking about today should not be strange, should not be completely new. We assume that you have mastered the calculation of those statistics, whether you want to calculate the measures of central tendency or the measures of dispersion. The assumption now is that you have mastered all of that. But quickly before we move on, can anybody help us? I need someone to briefly describe the measures of central tendency. What's that about? If we say measures of central tendency, what are we talking about? I know that you must have done that at the undergraduate level, and now you have also watched those videos. So quickly, measures of central tendency. Is anybody going to help? Okay, so since you're not talking, to save our time, if we have values in a particular distribution, for instance, if we're talking about students' course in FSS 840, if we have maybe this course like 50, 51, 52, 60, 70, and then you have another 50, 51, 53, 52, 56, 52, 52, 50, 53, 54, 55, then there is 190, there is 30, there is 55, there is 54, and there is maybe another 52. If we talk about measures of central tendency, we are referring to the typical score, or we're talking about the typical location of these scores on the scale. So if you draw a scale, if for instance we want to put this on a scale, we could have maybe 40 here, 50 here, 60, 70. Sorry, permit me to delete that quickly. Let's make it a little clearer. Okay, so we want to draw this on a scale. We want to represent this on a scale. Here we have 30, 40, 50, 60, 70, 80, 90. The first value I see there is somewhere here. The second value is 51. I can put a dot to represent that. Another one, 52. Another 60. Another 70. Another, I see another 50. I see another 51. I see 53. I see 52. I see 56, maybe somewhere here. I see another 52. I see another 52. I see 53, 54, somewhere here. This is not a very reliable thing. I'm just doing a rough representation, and then I can see 90, I can see 30, can see 55 somewhere here, 54 maybe somewhere there, and another 52. So if you look at this, if we draw lines to represent this, you'll see something somewhat like this. So the question that will be answered by central tendency is, where typically are these values? Where do they lie? Where do those values lie? Okay, so that's what we want to find out. So measures of central tendency will show you where you find the values typically. And I can tell without doing any calculation that the typical value will be somewhere around 52, for this distribution. So that value that is typical, where you have the majority, where you have a value that can represent the entire distribution. That is your measure of central tendency. And there are several of them. We have talked about the mean, the mode, the median. On the other hand, while measures of central tendency tell you where you can find the values typically, the measures of dispersion, on the other hand, will tell you about spread, how dispersed. That's why we say they are measures of dispersion. How dispersed are they? Are the values clustered around the same point on the scale? That is, do you have the values distributed somewhat like this, or do you have the values distributed differently, maybe having a wider spread? Okay, so that is what the measures, and that's the difference between the measures of central tendency and the measures of location. So while the measures of location are showing us where on the scale typically our values lie, the measures of dispersion show us how dispersed, or if you like, you could say they show us variability within the distribution. And these are very important measures in statistics. Typically, if we have figures in a distribution, if, for instance, you have ages of students, or you have income, and you want to know about, on the average, what people earn, or you have maybe you have information about the weather, and you want to know typically what the Nigerian weather looks like. It's possible already that you have information for different days in Nigeria, but you want an average, you want to find out what is typical, then you should be interested in measures of central tendency. But if you want to also know about the spread, so it may not be sufficient to say, I know what the average temperature in Nigeria is. It may also make sense to have an idea of the spread, because the temperature won't always be that average. Sometimes the temperature may be extreme. So if the temperature is extreme, how far can it go? So it is the measure of dispersion that will show us that will show us the spread of those values within a distribution. Okay, so first, it's important that we know the value or the use of these statistics. They guide us when we're making decisions in the design of studies. So if I want to design a study, and I want that study to be reliable, if I want the study to be valid, then I need statistics. I will also need statistics to draw reliable conclusions and then make inferences. And you'll be learning about that in inferential statistics. To make inferences about the general population using results from a sample that you have drawn from the general population. So these are some of the things that these statistics will help you to achieve. Then we also use them to evaluate programs and policies. We want to know whether a program is effective or not, or you want to compare two programs so that you know which one is more effective. If you also want to know how you can improve a particular program that you are implementing, you need statistics, because it's with statistics that you can get reliable information on maybe your performance indicators, and then you can compare different programs. Okay, it's also used for measuring abstract concepts. For instance, if I say knowledge, well, knowledge is an idea, and I may want to measure knowledge. So to do things like that, to quantify complex social concepts, we need statistics. Sometimes we create scales and indices to measure such things. I may want to measure, for instance, attitude towards a particular law. I may want to measure attitude towards gender-based violence, for instance. Attitude towards gender-based violence is very abstract, but with statistics, I am able to measure it, to quantify it. And then because we're able to measure these things using statistics, we can also, or we will also have enhanced understanding of those social issues, have deeper understanding. We also use statistics to understand those things we refer to as chance events. For instance, if you're in a class of 50 people and then you're told that 10 people will be selected as beneficiaries of hostel accommodation. The question then is, what's the probability that you will be one of those 10? Statistics can help us understand that. And even in mundane things like gambling, you can predict the outcome of some chance events. For instance, if I'm playing a game that involves the rolling of dice, I am very likely to get better outcomes. I'm able to take decisions that are based on a scientific approach to those chance events than somebody who doesn't understand how the so-called chance events are affected by probability theory. Okay, and then if I want to make predictions, if we want to do forecasts, including your weather forecasts, all those things are based on statistics. We can make projections with statistics, and we can make better decisions. Also, we're able to better understand complex systems if we have a fair understanding of statistics. And then when we're reading reports, we need a fair understanding of statistics to make sense of some of those reports. For instance, if you're reading the reports that the top quintile in the population is responsible for maybe 80% of the production. Someone who doesn't understand statistics will find it hard to make sense of that kind of statement. So for that reason, it's important that we have a fair understanding of statistics. Also, to inform public policies, inform planning. If you use statistics well, then you can get better data-driven policies. Statistics would also enhance our understanding of those trends in health, trends in social variables, in economic variables. Statistics will help us. And then statistics will also inform resource allocation and planning. For those of us who are interested in business, statistics would also help us to make better business decisions. Okay, so the question we then need to ask is, why should we be interested in measures of central tendency, and why should those things matter? They matter because they provide summary statistics. That is, you can collect information from thousands and thousands, and if possible, millions of people. But if you're to present the information, you'll need to be able to present the information in a very succinct way, in a simple way that people can easily make sense of what you're saying. Imagine, for instance, that I have collected information about the income of 1 million Nigerians, and I am to report that. It will not make sense for me to start saying the income of the first person is 50,000, the second person 51,000, the third person 120,000, the third person, and then I want to count all the way to 1 million people. That definitely does not make sense. But it will make sense for me to say that the mean income of Nigeria is, and I give a figure. If I say the mean income is maybe 75,000 naira per month, that makes sense. People can relate with this than for me to start giving figures. And the idea is that this figure that I have given is representative of the entire population. I don't need to give the salaries of 1 million people. Also, the measures of central tendency can help us understand patterns and trends. For instance, it's possible for us to see that the mean income in let me just erase this quickly. So it is possible that I show that the mean income does this look like anything familiar to you? Anything you're familiar with?
Yes.
Yes,
Map.
Map of Nigeria.
Okay, but I think I can do better. So let me try again. Okay, so let us assume, for instance, that I have statistics that the mean income here is 50,000. Here it is 150,000. In the South, the mean income is in the South, the mean income is maybe 75,000. In the Southwest, Southeast, maybe 140,000. The North Central, maybe 180,000, and here maybe 40,000. So already I can see a pattern. I can see variation across regions, even though the overall mean for the country is maybe 75,000. It is also possible for me to see trend over time. That is, I have statistics showing that in 1980, the mean income was maybe, let's assume, let's say 20, and this is 40, this is 60, this is 80. And then in 1990, I can see that it has grown to maybe 38,000. Then in 2000, it has also grown further to 60,000. So I can see patterns with these measures of location. If I use them appropriately, we can easily see patterns, and we can see trends also over time. And then they also make it possible for us to compare. For instance, I can compare the mean income for the Northwest with the mean income in the North Central. There are tests like the t-test, for instance. I can use the t-test to compare the mean of one the mean for one population or sample, compare it with the mean of another sample. Okay, but without these measures of location, it's not possible to do things like that. Okay, you'll know right now that the most commonly used measure of location is the mean. We use it a lot, and it is for a number of reasons. One, it's easy to compute. Two, it is a measure of location that considers all the elements in the sample. It does not leave anyone out. Okay, so so the mean is the average value, but the challenge with the mean is that it is sensitive to outliers. And this is what we mean by it is sensitive to outliers. If I collect information about 5 people, about their income, the first person earns 50,000. The second person earns 55,000. The third person earns 56,000. The fourth person earns 54,000. And then the fifth person earns in a month 2 million naira. Now, which value here does not look like the rest? Which one is an outlier? Which one lies outside the
2 million naira. 2 million naira.
Okay. 2 million naira. Let us calculate the mean with this outlier, and let us calculate it without the outlier. So I'm waiting for figures in another 30 seconds. If we calculate the mean with the outlier, and if we calculate the mean without the outlier, what are the values we have? And I should point out that everybody needs a calculator, a scientific calculator for this course. Everybody, it is compulsory that you get a scientific calculator.
So without the 2 million, the mean is 53,750. But with
53,750, okay?
But with the 2 million, it is 443,000 naira.
443,000.
Yes, sir.
Naira. Okay, now look at these two figures. Do they look alike?
No.
They don't look alike. If we are to use the arithmetic mean to represent a typical value here, do you think 443,000 is a good measure of location?
No, it is not.
It is not. Why do you say it is not?
Because the outlier has affected the outcome of the data. So it's not
Okay.
able in the majority of people in that location.
Excellent. Because this mean is not representative. It misrepresents. It misrepresents the distribution. It is not representative of this distribution. It gives the impression that an average person in that sample earns over 400,000 naira a month. But will you say that is correct?
No, sir.
It is not a true. Of course, statistically it is correct, but it is not a true representation of the measure of. It's not a true representation. It's not a typical value. Okay, so for that reason, we'll say that the mean sometimes it's not a good measure of location because it is too sensitive to outliers. Okay, in that case, we will look at the median. You see, the median is the middle figure. If you calculate the median for these values now, 50, 55,000, 56,000, 54,000, 2 million. Of course, you remember that to calculate your median, what's the first thing you must do?
You must arrange in ascending or
Okay.
descending order.
First, you need to arrange them. Thank you. So, and to arrange, let us try to arrange those values. If we're to arrange them, we will put, we'll say first, 50,000. After that, we have 54,000. Am I correct?
Yes, 54,000.
After that,
55,000.
55,000. After that,
56,000.
56,000. After that,
2 million.
2 million. Now, what is our median in this case?
55,000.
It is 55,000 because it is the figure at the middle. So our median is 55,000. Now, if you remove this outlier, if you want to find the median, you'll still discover that the median will be somewhere around that. Because if you remove the median, the two middlemost values will be 54,000 and what? And 55,000. So your median will be what? 54,500.
54,000 plus.
Okay, so if you use 54,500, if you use the median, you'll see that the median is robust. Robust in the sense that it can withstand outliers. That is, even if you introduce outliers, like they say, no shaking, it remains very stable, so to say. But the mean is not that stable when you have outliers. Okay, and then you know the mode. The mode is used when you're dealing with categorical variables. So if, for instance, you're talking about ethnic origin or talking about sex, then you can talk about the mode. But the mode is not a very good measure of location when you're dealing with numerical variables. Okay. Standard ways of presenting our measures of location. So let me quickly point this out. You should, when you're collecting data or analyzing data, you need to be very careful. You need to keep in mind the the different levels of measurement. And we assume that you are familiar with levels of measurement. You should have done this at a lower level, maybe at the undergraduate level or something. But there are different levels of measurement. Variables can be measured at the nominal level. That is where you have categories that are different only in names. Examples: sex, religion, whether Christianity or Islam or traditional religion, or ethnic origin. It can also be ordinal. When you have ordinal measurement, it means that you're talking about things that can be ranked. For instance, it's possible that you have maybe highest level of education, where you have highest level of education with categories like tertiary. This is ordinal because those categories can be ranked. The highest being tertiary, you can have secondary, you can have primary, and you can have no formal education. Even for a variable like degree classification, like first class, second class, upper. Ordinal just means that they are ranked. There are categories, but those categories are ranked. Second class, lower, third class, pass, and so on. So these, you know that you can't put them in just any kind of category order. You have to follow a particular ordering. You can't. Okay, so you can measure at the nominal level, at the ordinal level, and you can also measure at the interval and ratio levels. These ones are numbers. Here you have numbers. Here, these first two are categories. Okay, nominal, ordinal, categories, interval, ratio, numbers. Okay, if you're measuring any variable that is, if you're dealing with any variable that is numerical, the ideal thing is to measure that variable as a numerical variable, because if you measure it at a lower level, that is, we're indirectly saying that these different levels of measurement are also ranked. The lowest rank or the lowest ranked is nominal, above it is ordinal, above that is interval, and above that is ratio. So whatever you can measure at the ratio level, don't measure at a lower level. Prioritize the highest level of measurement. So let us assume, for instance, that I am dealing with a variable like age. When dealing with age, I can measure age numerically as numbers. So it does not make sense for me to use age categories. The reason is that if I use age categories, this thing I am talking about, I say it every year, but students will go to the field and do the exact opposite. If we tell you now to do a study and ask people and collect information about age, people will still use a category, but it is wrong. If you do it that way, you limit yourself and you lose so much. The ideal thing is to collect age in years, and then the computer, you can now create categories. Okay, but if you are dealing with a variable like age, the ideal thing, like I said, use actual ages so that you can say at the end, mean age is 25.2 years. If you use categories, it becomes difficult, if not impossible, to get this. Okay, so you should present. Yes, you can create, you can give a command that will have something like this: age categories. Then you can have maybe 20 to 29, but you should not present 20 to 29 in your questionnaire. It is wrong. It is after the data collection that you can now create categories. You can give the command for the computer to present this, to categorize. So 20 to 29, 30 to 39, 40 to 49. Let us assume that we studied people between 20 and 49 years. So here you will put the frequencies, 13, 15, and 12. And then you can put the total, which is 40. You can calculate the percentages. So this is a good way of presenting your statistics, but it will also be good to provide the mean. And so you can say the mean is 31.6 years. You can put a semicolon and also say the standard deviation is 5.2 years. Now, if you present your table with this distribution without the statistics, then that's incomplete. It's always good that you provide information about the location, that is what's the typical score like, and then also provide information about maybe the spread, and the standard deviation will do that for you. Okay, but you can also use some graphs to represent your variables. If you are dealing with a continuous variable, you can use histogram. Histogram has bars that are connected. Or you can use bar charts, especially for categorical variables. The bar chart has bars that are detached. We use detached bars because they are not connected. They are not in any way. For instance, if I say religion, you can't have boundaries that are connected. This is a nominal variable, so you can use this maybe for categories, but it is not suitable. The bar chart is not suitable for continuous variable. The histogram is suitable for continuous variables. Okay, it's also possible to represent some of these things using the pie charts. So that's another graph that's used. The pie charts can be used to represent to summarize, but as much as possible, don't have too many categories in your pie charts. If possible, use it when you have only between or maybe less, 5 categories or less. Okay, and you can use these for different types of data, including categorical and also continuous variables. But of course, as much as possible, it should be clear. Sometimes people use percentages instead of just putting the degrees, so that they're easy to understand. They're easy to so that people can easily understand them. Okay. Then, so you remember we said earlier that when you have outliers, it's not very safe to use the mean. Also, when the distribution is skewed, that is, the distribution is not normal. And I hope we'll talk about the normal distribution. When you say a distribution is normal, it means that that distribution is symmetrical. Something like this, it is bell-shaped. The left side looks exactly like the right side, okay? In a typical normal distribution, the mean is equal to the median because it is a normal distribution. And it is also equal to the mode in a typical normal distribution. The mean is the mean divides that distribution into two equal parts, and those two equal parts, those parts are identical. The left side is identical to the right side in a normal distribution. Okay, but if the distribution is not normal, for instance, if you have a distribution somewhat like this, that is a distribution that has a long tail to the right, in which case you'll say it is positively skewed. That distribution is skewed. You have more, you have a longer right tail. In that case, it will, the median will be a better measure because the mean would have been affected. The mean would have moved rightward, and then the median, like we've been saying, is more robust, so it stays more at the middle. So it won't be good to use the mean when you're dealing with a skewed distribution. It will be better to use the median. Okay. But if the distribution is normal, the mean is a good measure of location. Like we've been saying, when dealing with the categorical variable, it's good to use the mode. The mode is good. I mean, if you're dealing with a categorical variable, you can't even calculate the mean. Imagine, for instance, that I'm talking about religion with categories like Christianity, Islam, traditional religion. We can't possibly be talking about the mean religion. It doesn't make sense because it's not numerical, it's not interval ratio. So the only thing we can talk about in this case will be the mode. Okay, so we've talked about the sensitivity of the mean to outliers, but the limitation of the median is that it does not provide a complete picture. It does not provide a complete picture in the sense that there may be some outliers, some high earners, for instance, in our distribution. The mean ignores them. The median ignores those high income earners. Okay, so let us talk about these, the measures of dispersion. And I assume also that you have gone through all the videos. So let's pause for 2 minutes. Should I take reactions?
Can we have the two slides?
Can you what?
Can you please show us the last 2 slides?
The last 2 slides. This?
Yes.
Okay. You have anything to say about them?
No, sir. I'm taking notes, sir.
Okay. So before we go on, let me just
Hello, sir.
yeah.
Good afternoon, sir. Ola Aziz is my name. I just want to
Okay.
remind you, I just want to tell you that this will be the first time that you are taking the part-time class. This will be the first time that you are taking the part-time, or if I'm making any mistakes, I would like you to kindly correct me.
This is the first time. What department?
Mass communication.
This is our first class.
Well, yes, this is the first class actually. But before now, we shared videos for everyone to watch. Did you see them?
Sir?
No,
I
it was
do.
not
No, we did not see them all.
Sir,
No, see, not
I
see
do,
them.
but I've not read it.
I just
Just
got
read
the
it.
video 15 minutes ago when the class already
We did not see
started.
any video also. This is a
You did
master's disaster management class.
you did not see any video.
No.
Yes, sir.
Hello,
No,
Peter.
sir.
We saw the video in mass communication.
I saw the video. Hello, sir. I saw the video, but we haven't been a chance to go through it.
Exactly.
You have not been
Sorry,
chanced.
sir. I didn't see the video.
You did not
Okay,
see
so
the
if you
video,
have not
not yet.
been chanced to go through the videos, hold yourselves responsible. Okay? The idea is that you will go through those videos, not just going through, you'll study and learn how to do the calculation, but it's not late. You can still go back, watch all the videos. We have shared those videos. Where is Peter? Where are those who got the videos? Peter is meant to be, and yeah, maybe others should have reached out to.
Videos, but it was shared about
We never got the video.
Hello, sir.
Those of
Hello,
the
sir.
of maritime studies.
Hello, sir.
Maritime.
Can you?
Yes, Chido's here.
Okay, please, sir. Can you slide to the next slide, please? Sorry.
To the next slide.
Yes, please. And this is our first class. We are the MPA part-time. So this is our first class.
Just make sure. Yes, this is the first class, actually.
Yes,
Hello,
and
sir.
we are getting this information.
Hello, sir.
So, yes, is that Comfort?
No, sir.
Okay, who is speaking?
It's Motorayo, sir. Good
Okay,
afternoon, sir.
Matsurai. How
Yes,
are
I
you?
wanted to ask, sir, if we can get a copy of this slide.
Yes, you will get the slides.
All right, sir. Thank you, sir.
Comfort.
Excuse me, sir. Excuse me, sir.
Hello, Comfort Oluwaseita. Yes, you've been raising your hand.
Yes, sir. Good afternoon, sir. Please, I want to
Good
confirm
afternoon.
something you spoke about during the course of the lecture. You made a statement about the categories, the age categories, that when we are on the research field, we shouldn't categorize it until we are done with obtaining our data. Then we want to impute it in our data analysis, so we can now categorize it and confirm the frequency. So I just want to confirm, are you stating that on our questionnaire, for example, I know for interview, you obviously have to ask your interview sample method, you obviously have to assess sample method, sorry, interview research method, you obviously have to ask your participants their age. But for questionnaire, are you saying that we are going to ask them for their age as well, like just put age, then dash, and then they fill it themselves?
Yes, that is the correct thing to do.
Wow.
Hello,
Oh, wow.
Comfort.
Yes, yes, sir. It's just new
Hello.
to me. Yes, yes, sir.
Yes. Yes, it's new to you. That's why you're in school. Okay, but I know that many of you will still go to the field and do the exact opposite. Can you hear me?
Yes, I can hear you correctly, sir. I can hear you very well, sir.
The correct thing to do is for all those numerical data, you should leave them open. Whether you're talking about age or you're talking about income. So, because that's the only way you will be able to get these descriptive statistics we're talking about. if, for instance, you give them categories and they choose from those categories, of course, it makes, well, you will think that it will make your work easier when you're doing your analysis. But the reality is it complicates your work because you won't be able to get statistics. If, for instance, we ask you, okay, so tell us the standard deviation of the distribution, you can't produce that. If we tell your computer can't even produce it. If we tell you to produce the mean income or something, you can't get those things. Okay, because you would have represented the categories with codes. Maybe you say 20 to 29 years, you code it 1, 30 to 39, you code it 2, and so on. You can't get statistics. That's the reality. And I know that no matter how many times I say this, hello?
Yes, sir. For a moment.
Yeah, yes, sir.
Okay, so Comfort, I hope I have answered your question.
Yes, you did, sir. Very much. Thank you very much, sir.
Okay.
Excuse me, sir. Excuse
yes,
me, sir.
Yes, sir.
I have a question here. My name is Perekeme Odon, and from your mean media mode relationship with frequency distributions, you made mention of the frequency distribution with symmetrical frequency curve.
Yeah.
And you made mention about the positive skewed, that is frequency distribution.
Yes.
Are they related to what? No negativity there when the negativity skewed frequency. What about the distribution there?
Yes, it's possible that this distribution is also negatively skewed. When the distribution is negatively skewed, it's the same thing. You can't use the mean. If you use the mean, you have a low figure or a figure to the left of the mean, to the left of the median in this case now, representing the entire distribution, and that's not a good thing. The ideal thing is that you have a typical score. Okay, I don't know whether we will have the time to go into normal distributions. If we do, I'll run through that quickly. Maybe you'll understand better.
I saw the diagram there. That's why I'm asking. The other one, from down went up and still came down again. Then the other one from the down here, went up and went to the other end. I didn't see the other diagram.
Okay, so okay, in 2 minutes, I'll run through this and then.
Sorry, sir, I have a question, sir.
Is that Temitope?
No, this is Abayomi, sir.
Please, let us take Temitope first. She has been raising her hand for a long time.
Good afternoon,
Temitope.
sir.
Okay,
Yes, sir.
quickly.
Good afternoon, sir. My name is Temitope Richard. Sorry, please, this is actually my first class in statistics. So I'd like to find out what the mode of exam is. Is it MCQ or MCQ with theory?
I think it's MCQ. I also it should be. I don't even know, but I don't like that question. I don't like exams, and if I have my way, there will be no exam. Okay, I'm not teaching you because of the exam. Okay.
I know, sir.
Yeah.
Thank you.
So it's very likely it's a MCQ, but it's the part of the whole thing that I don't like. Exam. Okay, Aisha. Hello, Aisha. Ibrahim.
Good afternoon, sir.
Good afternoon, ma'am.
Sir, still on the age range. Sir, what if your research is based on like just youths? Do you still have an open blank open page for the age?
Yes,
or you have to
yes. You
Okay.
should always use open-ended questions for numerical data because that is the way you'll be able to get statistics.
Okay, sir. Thank you, sir.
If you
Yes.
if you use closed-ended questions, there are some statistics you can't get.
Okay, sir.
Okay.
Okay, sir. Thank you.
Okay. Yeah. Adelapo.
Okay, sir. Thank you so much, sir. So my question is, the part that you said that we should use the median, and even if we add the outliers to it, it will not really be obvious. I don't really get that part. Does it mean that it will reduce the value, or it will just
It means that the median is robust. And what do we mean by robust? If you bring an outlier, it does not change the median significantly. The median is resistance in a way. Let's use that word. It is resistance to outliers. So even if you bring one big figure from outside and you add it to the distribution, it does not move the median. Let's put it that way. It doesn't move the median, but it will always move the mean. Akwayami, do you understand that?
Yes, sir. Yes, sir. I get it. Thank you, sir.
Okay, Yami, quickly.
Okay, sir. Good afternoon, sir. My name is Abayo. Please, I just wanted to confirm. You said we cannot use mean for religion, sex, and some other ones. Please, I just wanted to confirm which mode are we using for those?
You will use the mode. Mode is the category with the highest frequency. That's what you'll use.
Okay. Okay,
Okay.
sir. Thank you, sir. Yes, sir.
Welcome.
Thank you very much, sir.
Okay, I think we should. Okay, we still have one more question. After this one, we have to move on. We will have very little time. Oluwadamilare Adeomi.
Yeah, thank you very much, sir. Good afternoon, sir. So, I have a question in response to the question someone asked about the outlier. The reason why we have to use median when we have an outrageous outlier there. So my question is, what if the outlier is at the middle? Probably we have about 3 outliers at the middle of the data. How do we go about that?
Mr. Adeomi.
You have to arrange to get the median.
Yes, that's the point. When
So
after
even
arranging,
if the outlier is at the middle, by the time you arrange, it moves to the extreme.
Yeah, that's
to the end. So it can't be the median in any case.
Hello, who is explaining that? Is that Temitokwe?
Yes, sir.
Temitokwe Orisha Feijimi.
Yes,
Okay.
sir.
Excellent explanation there.
Thank you, sir.
Okay. So that shows understanding. It shows you understand what we're talking about. So you can't have an outlier at the middle of the distribution. The outlier will be an extreme figure, either to the right or to the left. Are we together?
Not really, sir.
Yes, sir. Thank you, sir. Understood.
So does that mean
really.
that we will first of all apply the mean, like arranging from ascending order?
Yeah,
so
we have to arrange that.
Hello,
Yes.
the reality is when you're using what do you call it? When you're analyzing data in real life situations, you will not do this manual arrangement. You will just feed in your figures, and the computer will do all those things, the arrangements. Nobody sits now. If you conduct a survey and you have maybe 1,000 respondents, will you sit down to arrange those 1,000 incomes or salaries from the lowest to the highest. You won't do that. The computer is going to do all those things for you. But you just need to understand the logic behind it. That's what we're saying. Okay, so yes, you will arrange it. It is correct to say so, but you will not arrange it because it will be arranged either by Stata or by SPSS or by Excel, depending on what you're using. If you feed in figures now in Excel and you give the command for Excel to give you the median, you won't need to arrange those values manually. No, but Excel can deal with all of that, can handle that and give you the correct median, can give you the correct mean. Do we understand that?
Yes, sir. Thank you.
Yes, sir. Thank you. But excuse me, sir, there's one thing. Does removing outliers increase mean?
It depends on where the outlier is. If the outlier is to the extreme right, if you remove it, it will reduce the mean. If it is to the extreme left, if you remove it, it will increase the mean. I don't know whether you understand that.
Yeah, that is if you remove a number that is lower than the mean
will increase, exactly.
Okay.
So it depends on where the outlier is. The outlier does not have to be a positive outlier, and it does not have to be a negative. It can be either.
Okay, and the denominator also drops too.
Exactly, the denominator will drop by 1, but sometimes the dropping is of no effect if the sample is large.
Okay.
Are we together?
Oh yeah.
If for instance, if your sample size is 1,000 and you remove 1 from it, it's not going to change anything. But if your sample size is 5 and you remove 1, it will make a difference because that's a small sample. But if you have a large sample, it's not going to change anything, at least not significantly.
Okay, yeah, there are lots of questions to ask, but we in a lecture. But is there any best statistical test for outliners?
Just go online. If you go online, I mean, there are lots and lots of resources. If you go to YouTube and you just type dealing with outliers, you will see far more than you need. Okay, you just need to have that first for knowledge, and you want to know.
Yeah, thank you, sir.
Okay, you're welcome. Okay, so let us go on. At the end, we will take more questions. The co-hosts, please don't keep people outside waiting in the waiting room for too long. Okay, so let us go on. So let us talk about the measures of spread. Okay, you remember that we said earlier that there are measures of location, which we have dealt with to a large extent. We also have measures of spread. Okay, the simplest of them is the range. If you go back to our videos, you'll see how to measure the range. But we also have the variance and the standard deviation. And that standard deviation is the most commonly used measure of spread. Okay, if you go through the videos, you'll see how to calculate the standard deviation. Then you also have the interquartile range, which is another robust measure of spread when you're dealing with outliers or you have a skewed distribution. Okay, so to represent these values, tables are important. You remember earlier said you should present your mean if you're dealing with income. So if you present a table that has income, for instance, you have things like 30,000 naira to 39,999, and you have 40,000 to 49,999, 50,000, and so on. At the end, it is important that you provide us the mean income. So mean is equal to 46,200. Sometimes you'll see things like plus, minus, then people put the standard deviation, SD. So you should report the mean and also report the standard deviation. So whatever the standard deviation is, you should report it. I'll look for a way for us to quickly look at how the main, how the standard deviation looks typically in a normal distribution. Okay, so so the variance, the standard deviation is the square root of the variance. If you look through those videos, you'll see these things. And then if you want to compare variation into what do you call it now? Into distributions, the ideal thing is your coefficient of variation. If you watch the videos, you'll see the video on measures of dispersion, you'll see the coefficients of variation there. So if I want to compare two distributions to see which one is more dispersed or which one has greater variability, greater variation, then I should be looking at the coefficient of variation. So the range just tells you the distance between the minimum value, the lowest value, and the maximum value. And that range is so the range really doesn't tell you what is in between, it just tells you the gap or the distance between the lowest and the highest. The variance can also be sensitive to outliers. You remember that we've been using this word, sensitive. Sensitive, when you say something is sensitive to outliers, it means that when there is an outlier, it responds to it. Okay, and that is not a positive thing, it's a bad thing. That's a measure of location or a measure of dispersion is sensitive to outliers, which means that it is not very robust. It can't withstand the inclusion of outliers. Okay. Also the standard deviation, because the standard deviation comes from the variance. And like I said, the standard deviation is the best indicator because it's easy to interpret. It's easy to, we can discuss in terms of standard deviation. So the standard deviation is also sensitive because it's derived from the variance. And then we have the interquartile range. The interquartile range can be robust and less sensitive to outliers. Okay, let me quickly take you through. I was saying that I would like to show you quickly the normal distribution, so that's what we've been talking about. So this I am going to run through very quickly about the normal distribution. So we expect that you would have learned. So please, if you don't have those videos, we shared those videos about 2 weeks ago. Please reach out to those who have the videos, let them share with everybody. Okay, let them all, let everyone study those things. So the expectation is that now we're familiar with we know how to calculate the difference. At least we understand the logic behind the measures of location, the measures of dispersion, the measures of relative standing, and then the normal distribution. So if you say a distribution is normal, you mean that that distribution is symmetrical around the mean, and the normal distribution itself is a hypothetical distribution, which means that in reality, well, yes, it may exist in some natural data. For instance, if we're talking about heights, the height of people, it is normal in a way. Okay, the attributes of a normal distribution. One, it's a population of an infinite number of elements, which means that there is no end, there is no beginning, no end. It's infinite in terms of the number of elements. The second one is that it is bell-shaped, and then the third one is that the mean, the median, and the mode are all equal. They divide the distribution into two equal halves. The mean is at the middle. The mean value is the same thing as the median, and it's the same thing as the mode. Then we said also that it is symmetrical about the mean. Then it is asymptotic to the x-axis, which means that the tails get closer to the x-axis as those tails go farther from the mean, but the tails will never touch the x-axis because you can't close it. There is no end to, because you're talking of an infinite number of elements in the population. Now, earlier we were talking about the skewed distribution. If a distribution is humped to the left, which means that it has some extreme figures to the right, then you'll say that is positively skewed. So if you have something like this, you have a longer tail to the right, then you'll say it is positively skewed. But it's also possible that you have a distribution like this, which means that you have a longer tail to the left, and you'd say that is a negatively skewed distribution. If your distribution is positively skewed, it means that the mean will be higher than the median, and the mode will be lower than the median. And the opposite is what you get with a negatively skewed distribution, which means that the mean is going to be lower. Remember earlier, I think it was Odon that was talking about this. If you have outliers to the left, then you will have a mean that will be lower than the median. Okay, so if you look at this scores in a test, and these are real scores that we drill from a particular test, it is relatively normal. It's normal in a sense, not perfectly normal, but if you look at the calculations we did, the statistics, we have a mode of 14 and a median of 14, and the mean is also 13.88, which is approximately 14. Some people are in noisy places, some people are in marketplaces, and they are thinking that they are in class. They are not in class. They can't make the most of this. The ideal thing if you're attending an online class is that you go to a quiet place. Okay, let us move on. So that's about the normal distribution. I don't know whether we should be going into standard scores. That's a little, well, it shouldn't be technical for you. You are master's students, you are experts. Okay. So if you're talking about a standard score or the Z-score, you're talking about a conversion of distributions into distributions with a mean of 0 and a standard deviation of 1, whatever the standard deviation is. And this makes it possible to compare different distributions. So whatever the standard deviation is, a standard score or a Z-score will convert it to 1. Whatever the mean is, the Z-score will convert it to 0. So like I said, this makes it possible to compare the relative standing of scores in different distributions. Okay, and there is a formula for converting the Z-score, converting scores into Z-scores. You just subtract the mean from that particular value and you divide it by the standard deviation. For instance, if you have scores like 3, 4, 5, 6 in a distribution, to convert it to Z-scores, first you need to find the standard deviation. And if you find the standard deviation here, you have a value of 1.58. And so to convert 3 to a Z-score, in this case, you'll say 3 minus 5, which is the mean. That's the mean. And this is our X. No, not X bar, sorry. That's our X. You divide it by the standard deviation, 0.58, which is the SD. So that will give us a Z-score of minus 1.26. Now, because the mean has been converted to 0 and the standard deviation to 1, any negative Z-score means that that particular value is less than the mean. And any positive value means that the value is greater than the mean. Now, if the value is 0, the value is equal to the mean. That's for a Z-score. So if you now have a standard normal distribution, it means that you have a normal distribution that is also standard at the same time. That is, you're combining the features of a normal distribution with the features of standard distribution. Now, in a normal distribution, if the distribution is normal, 34.13% of the values will lie between the mean and one standard deviation above the mean. If the distribution is normal, then 47.72% of the values will lie between the mean and 2 standard deviations below the mean. And the same thing happens to above the mean, which means that on the whole, 95.44% of the scores in a normal distribution fall within 2 standard deviations below and above the mean. Then finally, 99.87%, that is almost all the values or the scores in a normal distribution fall within 3 standard deviations below and above the mean. And you can use your calculator to generate the proportions that you have for the different standard deviations. For instance, I said earlier, 34.13% of the scores lie between the mean and 1 standard deviation above the mean. Okay, what if it is 1.5 standard deviations above the mean? Then the value will be 35.31% of the distribution will be found within that range. Okay, and I mean, look at this example, for instance. If you say men have a mean height, of 68 inches and a standard deviation of 4 inches. You ask within what intervals do almost all the heights fall? Then that will be 60, almost all. Don't forget, it refers to 3 standard deviations below and 3 standard deviations above. So if 68 is the mean, if the mean is 68, sorry, I'm trying to get this. If the mean is 68, 1 standard deviation, 2 standard deviations, 3. Almost all the values will lie between 3 standard deviations below, -1, -2, -3, and 3 standard deviations above the mean. So which means that almost all of them will fall between, if you multiply 3 by the standard deviation, that gives you 12. Subtract 12 from 68, that gives you 56. Add 12 to 68, that gives you 80, which means that about 99.74% lie between this value of 56. Don't forget, 3 standard deviations below 68 is 56. 3 standard deviations above 68 is 80. So 99.74%, that is almost all the values, lie between -3 SD, that is between 56 and 80 inches. Okay, so this is just to show you how the standard deviation behaves. In a normal distribution, you expect almost all the values to fall between -3 standard deviations below the mean and +3 standard deviations above the mean. Okay, so you could get questions like this, for instance, asking you about the proportional heights that fall within 65 and 73, and so on. So I'm going to stop here right now. Are there comments? Questions?
Lisa, can we have access to the recording?
Yes, it's on YouTube. I have shared the link already. So if you go to
Thank you, sir.
on
But please,
YouTube,
can you help us with the slide?
And the slide as well.
Yes, we need the slide. The class reps should have it, and then can get
okay.
from them.
I will share this. I will share the slides with you.
Thank you, sir. The slide are recording.
Thank you very much, sir.
The
Thank you, sir.
recording,
Thank you so much, sir.
I mentioned that
Thank you very much, sir.
it's on YouTube. You're welcome. It's on YouTube. I'll share the link again. If you go to my YouTube page, you should find it. But I'll share the link nonetheless.
Okay, the link is
Hello, sir. Can you hear me, sir?
Yes, I can hear you.
All right. Thank you very much for a detailed class. So please, some of us are not really acquainted and familiar with anything that has to do with mathematics. So please, is there a way to further simplify and make it simpler for especially mass comm students for us to understand better? Thank you, sir.
Okay, so Ibe, what I'll encourage you to do is start with those videos. Go and watch the videos. We have shared videos with you, YouTube videos. Watch them. At least you can pause. You can pause and play back if you don't understand. Okay. So that will be my advice. Start with that. Watch the videos. And I think I tried in the videos to simplify these things. But the most important thing is to understand the logic behind these things and to understand when to use them and how to interpret them. What exactly do they mean? Okay.
Thank you very much, sir. Thank you.
You're welcome. So on that note, I want to bring the class to a close. I wish you the very best.
Thank you, sir.
Hello,
there is one comedian here, Eduadeni 7, who wrote, "The class is interesting. Can you Kuku be having more of it online?" And for people like you who rely on God to have a D, you are aiming for a D. That's dangerous.
very dangerous.
Because you may end up with an F if you aim for a D. So I encourage you to aim for an A. If you miss the mark, you can get a B or a C. But to aim for a D is dangerous. Okay, so on that note, I wish you all a happy weekend. Bye.